Hello class, so in this video, we're going to discuss the applications of first order differential equation. So introduction muna tayo ng konti about its applications and then we're going to discuss a specific one which is escape velocity. So as we have discussed last time, so ordinary differential equations, they have important applications and are a powerful tool in the study of many problems in the natural sciences and in technology. So they're extensively employed in mechanics, astronomy, physics, and in many problems of chemistry and biology. So we have discussed this last time na ang differential equations, it is useful in a sense that it can be used to model physical phenomenon. And this physical phenomena, pwede nating mahanap yung mga parameters na nawawala through differential equations. So, bale, yung pinag-aralan natin in the past semester, past na weeks, including yung kung paano mag-solve ng first order ordinary differential equations, that is in preparation for this topic. Kasi syempre, in order for us to utilize differential equations, kailangan alam natin kung paano siya gagamitin. Ayan. So, para mas maintindihan natin kung paano siya na-apply, let's start with the Earth's escape velocity. So, for the next 3 na topics, specific examples or application na pag-aaralan natin, yung pag-apply ng differential equation, gagamitin lang natin siya kumbaga sa pag-derive ng mga formula, ganun. So, ibig sabihin nun, after nating ma-derive yung formula, after nating mahanap yung particular solution, mag-integrate, etc., makukuha na natin yung mismong formula nang hindi na tayo kailangan paulit-ulit mag-derive, mag-differentiate, mag-integrate. So, but later on, with the discussion, magkakaroon pa tayo ng mga examples or applications kung saan every time na ginagawa natin yung example na yun, minomodel natin siya on the spot. Then after natin siyang i-model, tsaka pa lang tayo magde-derive. But for this one, to be specific sa Earth's escape velocity, kukuhanin lang natin yung formula. And ipapakita ko kung paano natin nakuha yung formula gamit ang differential equations. Ayan, so Earth's escape velocity. So an equation relating the escape velocity of the Earth daw to its parameters can be derived using differential equations. So yun naman yung sinabi ko kanina. Tingnan natin tong figure na to. We have itong round thing na to, that is the Earth. Capital R, that's the radius of the Earth. And then meron tayong small letter r, that is the distance of the Earth from an object escaping its velocity. Or escaping its gravity rather. So yung velocity at which kailangan na ang isang object ay ma-reach niya para makaalis siya sa gravity ng Earth. So, tinatawag natin yun na escape velocity. Ang gusto nating mangyari with this lesson is pag natapos natin itong pag-aralan, at the end of the lesson, alam na natin or meron tayong formula to find the escape velocity. So, in order for us na makapag-proceed, kailangan familiar tayo sa mga to. Newton's universal law of gravitation, Newton's law of motion, so to be specific yung second, pati yung third actually kailangan din natin. And of course, differential equations. So let us start to derive the formula. Okay, so first na muna, we have Newton's universal law of gravitation. And it is stated that F is equal to G, M sub 1, M sub 2 over R squared. Now, discuss ko muna, ano ba yung universal law of gravitation? Ito yung law na sinabi ni Newton na any two objects, they have a certain level of attraction to each other. And yung attraction na yun, depende sa kung gaano kalaki yung mass nila tsaka yung layo nila sa isa't isa. So, para mas ma-visualize natin, halimbawa, ang dalawang planets, let's say for example, ang Earth at saka ang Venus, those are two heavenly bodies. Tapos, may attraction daw yung dalawa na yan sa isa't isa. Kasi syempre, may gravity si Earth, may gravity si Venus, kumbaga, or any object, basically, may gravity. And depende yan sa kung gano'n na lang siya kalaki. Kung mas mataas yung mass niya, mas mataas yung gravity. Now, kung yung Earth daw at Venus, meron silang certain distance from each other. Let's say that is yung R natin. And then may kanya-kanya silang mass. That's m sub 1 and m sub 2 respectively. And G is the universal gravitational constant. Then there is a force daw na humihila sa kanilang dalawa. Naghihilaan silang dalawa. And that is yung ating F. So, which in this equation, F natin is the force of attraction between two heavenly bodies. This is in newtons. G natin is the universal gravitational constant. Ito yung value niya. Then M sub 1 is M sub 2 is the respective masses in kilograms. And R naman is the distance between the centers of the object's masses in meters. So that is universal law of gravitation. So tandaan natin tong formula na to. Now, also, according din kay Newton, second law of motion naman niya, force daw is equal to ma. So, wherein force is, force in newtons, and then m is the mass of the object. This is in kilograms, and a is acceleration. So, dito, familiar tayo sa formula na to. Now, how can we relate the two? So, we can relate the two by, kasi, going back to this figure, we know that the Earth and this object, which is a rocket ship, ay meron silang parehas na mass, parehas na meron tayong distance from the center of the Earth, from the object, to the object leaving the Earth's gravity. So, we can also apply this law to that example. And the force na between the Earth and this rocket is equal to this one. But we know that in this rocket, ito ay nag-accelerate kasi nga paalis siya ng atmosphere, tapos meron din siyang mass. Then we can also get the force exerted by this object by using Newton's second law, which is this one naman. So force is equals to ma. So therefore, pwede nating equate yung dalawang to because they are actually the same force in respect to the example that we gave earlier or dun sa figure na pinakita natin. So therefore, if we equate the two, tandaan natin pangalanan natin yung m sub 1 saka yung m sub 2. M sub 1, this is the Earth. In this example, m sub 1 is the mass of the Earth. M sub 2 is the mass of the rocket ship. So therefore, kung apply natin yung second law dito, the m sub 2 rin yung gagamitin natin to denote its mass. So equating the two, we will have yung using the universal gravitational law. We have z m sub 1 m sub 2 over r squared is equal to second law of motion m sub 2 times a. So, gawin natin na acceleration na lang yung nasa kabilang side. Actually, kasi kakancel lang natin tong m sub 2 kasi parehas naman yan. So, we will arrive at a, our acceleration is equals to g m sub 1 over r squared. Now, si g, this is the constant. M sub 1, this is the mass of the Earth, which is also constant. So therefore, kung constant yan, para hindi na tayo masyadong maraming nakalagay na variables, palitan na lang natin siya ng constant na k. So instead of z times m sub 1, gawin na lang natin siyang k. Basta alam natin that k is equal to z times m sub 1. So thus, ang kakalabasan na equation natin class for acceleration is equal to k over r squared. So constant si k, r squared is nag-change yung value. Kasi syempre, habang lumalayo yung object sa Earth, lumalaki rin yung distance nila sa isa't isa. So if the object is at the surface of the Earth, then r is equal to the radius of the Earth r. And the acceleration is equal to the acceleration due to gravity, which is z. So kung yung rocket ship, nasa surface pa siya ng Earth, yung layo niya sa center ng Earth is obviously equal to capital R, which is the radius of the Earth. And yung acceleration due to gravity at that point is also equal to g, which is, ito ay 9.81 meters per second squared. So note that g, so ang gagawin natin ngayong class is since yung g na to is the gravity at the surface of the Earth, pwede natin siya kumbaga gamitin as initial conditions. So, ilalagay natin yung z dito, tsaka yung r dito, para ma-solve natin yung k. So, if we do that, ito yung kakalabasan. Take note class na r natin is equal to r, yung a natin is equal to negative g. Bakit negative g? Kasi syempre, yung acceleration due to gravity, it's going inwards. Papasok siya dun sa center of the earth, which is opposite kung saan yung intended direction mo. That's why negative yung g natin na nilagay. So, substitute natin, magiging negative g is equals to k over r squared. Now, ang k natin will be negative gr squared. So, kung nakita nyo, parang gumamit tayo ng initial condition dito. Now that we did that, we can now substitute the value of k. As long as the initial condition is nagsimula sa sa surface ng Earth, yung object before siya mag-leave. But take note class, kapag sinabi na hindi siya sa surface ng Earth nagsimula, then ibig sabihin, hindi ito yung constant mo. Iba yung value ng k mo. But for most discussions naman, the assumption is always, syempre, nagsimula sa Earth. Kasi hindi ka naman mag-escape velocity nang nasa a higher na area ka. So, substituting the k to the equation, we will arrive at a is equal to negative z r squared over r squared. So, this is our formula for acceleration. So, may isa na tayong formula. So, again, recap lang, g is constant, r squared is constant, capital R squared rather is constant. Itong R squared na to is hindi to constant. This is nagbabago yung value niya. Next, let's try to derive another formula for acceleration or another expression. So, tandaan nyo class na acceleration, this is defined as the velocity of an object at any given time t. So, it's actually a velocity per time. Kaya nga ang niya, di ba? Ang kanyang unit is actually meter per second squared. Kasi nanggaling yun sa meter per second over second. Kaya naging meter per second squared. So thus, we can actually express acceleration using its parameters pala, which is velocity and time. Note that if an object is accelerating, then its velocity changes as time passes by. Habang gumagalaw yan, depende sa acceleration mo, nag-change yung value niya. Because nag-change yung velocity natin kada segundo. So thus, a change in time will also reflect a change on the velocity of the accelerating object, which is, as we have discussed last time, that's actually a derivative. So kung ganun yung case, then pwede nating i-express pala yung acceleration as dv over dt. So ito na, napakita ko naman to na example nun last time. So, nagkaroon tayo ng another starting point para humanap ng value ng acceleration. And that is, express natin siya as a derivative ratio ng dv over dt. Now, yung nasa equation natin na previously ay in terms of r. Diba? Pag binalikan natin to, ang variable natin dito na independent is r. Diba? Kasi yung g at saka yung capital R, constant sila. So, nagbabago yung value ng a natin with regards to r. So, ang independent variable natin dito is r. But dito sa second equation natin, wala namang diba? Wala namang nakalagay. Kumbaga, it's not a parameter na r. So, para hindi tayo mahirapan, ang gawin natin class, i-multiply natin yung whole equation sa dr over dr para maging uniform tayo dun sa una-una nating equation. So, ang acceleration natin ngayong class will be dv over dt times dr over dr. Which is equal to 1 lang din naman, di ba? So, parang minultiply lang natin yung buong equation sa 1. Now, if we rearrange this, pwede natin gawin to as dv over dr tapos dr over dt. So, ganito yung kakalabasan. dr over dt, dv over dr. Now, hindi ba familiar tong dr over dt? Ito daw ay derivative. To be specific ng r, ang r natin is distance. Ang over dt, ang t natin as time. So, ano ba yung unit or parameter na distance over time? So, that is velocity. So therefore, pwede pala nating palitan si dr over dt ng v na lang because v itself, it's a derivative. It's an expression na nagbabago yung distance mo with regards to your changes in time. So palitan na lang natin siya ng v instead of dr over dt. So ang kakalabasan ngayong class ng equation natin is acceleration is equal to v dv over dr. Now, meron na tayong another equation for acceleration. Tapos may isa pa tayo kanina, which is this one. Ito. I-equate natin ngayon yung dalawang equation na yan. If we equate these two equations, we will arrive at v dv over dr is equal to negative g r squared over r squared. So yun, class, yung nakuha natin na equation. This is obviously a differential equation. Now, if we want to use this differential equation to solve the parameters, then what we have to do is we need to find the solutions. So kung napansin natin, itsura pa lang ng ating equation, this is a variable, separable differential equation. So kung ano yung napag-aralan natin nung nakaraan, kung paano i-solve tong ganitong klase ng DE, gagamitin natin siya. So the resulting equation natin, again, is a variable separable. Now, let us try to find the general solution. So, ang ginawa lang natin, yung v dv is equal to negative z r squared over r squared. So, nilipat natin yung r sa ilalim. So, andito yung dr. Ayan. So, we have z r squared over r squared times dr. So, sorry na wala yung dr dito kanina. Laser pointer. Ayan. And we can now directly integrate. We know that gr squared is constant. So, nilabas na lang natin siya. Tapos, ang meron tayo dito is r squared dr. So, we have r squared dr. This is already directly integrable. Kung integrate natin siya, magkakaroon tayo class ng v squared over 2 is equal to 2gr squared r raised to the negative 1 plus c. So, therefore, ang kakalabasan nito class is v squared is equal to 2gr squared r minus 1 plus 2c. Now, this is our general solution. Now, however, kung napansin natin, itong general solution natin, wala pa naman siyang nire-reveal sa atin na kahit anong value, di ba? Tsaka, bakit hindi pa natin siya magagamit? Kasi class, meron pa tayong arbitrary constant. So, ang gagawin natin class, kailangan natin ng initial condition para matanggal natin yung arbitrary constant. But take note, ano ba ang initial condition natin kapag ang pinag-uusapan is escape velocity? Ang assumption natin, class, nagsisimula ka at the surface of the Earth. And then, syempre, meron kang certain na initial velocity. So, let's say, for example, that initial velocity is vi. So, kung ganun yung case, class, substitute lang natin. Yung r palitan natin ng capital R, yung v palitan natin ng vi. So, mag-arrive tayo at this equation. We have vi squared is equal to negative 2 gr squared. Tapos yung r papalitan natin ng r, diba? So magiging r raised to negative 1, so makakancel yan, plus 2c. We can now get our arbitrary constant. 2c natin is equal to vi squared minus 2gr. We can now substitute this vi squared minus 2gr dito sa value ng 2c. So substituting 2c to the equation, we have v squared is equal to 2g r squared over r squared plus vi squared minus 2gr. So, this is our equation. Now, hindi natin gagamitin class yung buong formula na to. But meron tayong importante na kailangang analysis kasi kung ba't natin to kinuha. This is the model ng ating scenario, kumbaga. An object leaving the velocity of the Earth. This is the formula or this is the equation that describes that. But hindi naman natin kailangan malaman yung buong equation. Hindi natin siya kailangan gamitin. Kasi kung titingnan nyo, class, we have here two terms. Yung first term natin is 2g r squared over r squared. 2g r squared is constant. Tama, g is constant, r squared is constant, 2 is a number, so constant yung mga yan. Ang nagbabago lang yung value dito is yung r squared. So kung r squared yung nagbabago ng value, saan ba approaching ang value nung term na to? Where tong first term natin, nag-approach siya at what value? So balikan natin yung problem natin kanina. R daw, that is the distance of the object to the center of the earth. Now, imagine na papaalis na ng atmosphere yung object natin. Ano kaya ang mangyayari sa R natin? So, habang papalayo, rather, yung object sa center of the earth, syempre tumataas tong R natin. And pag tumaas yung R, ano yung mangyayari dito sa term natin? So, as R increases, the value of 2g r squared over r squared decreases. Bakit? Kasi habang tumataas yung r, lumalaki yung denominator natin. So therefore, class, itong term na to, this is approaching 0. So nag-a-approach ng 0 yan. Kung ganun yung case, class, then dapat yung initial velocity mo ay yung velocity ng object mo ay mataas. 'Di ba? Kung gusto mong makaalis sa gravity ng Earth, dapat mataas yung value ng v squared mo or ng v mo rather. So kailangan mataas yung value nito. So kung ito, habang lumalayo ka sa Earth, nagiging 0, ibig sabihin, this second term mo na vi squared minus 2gr should be greater than 0. So, yun yung assumption natin. Kasi na-imagine nyo ba, class, kung ito ay approaching 0, tapos ang value nito ay less than 0, then ang tendency, class, at certain point na ma-reach na yung value ng r, either titigil na yung pag-accelerate at pag-move ng object natin, ng rocket ship natin, tapos babalik na lang siya sa Earth. So, ganun, class, yung mangyayari. But, if the second term natin na to, itong second term natin, is mas mataas yung value niya kaysa sa 0, then ibig sabihin, may velocity pa rin tayo. So, ang assumption natin, class, pagtaas ng r squared, wala na to. So, kung mawawala yan, dapat, itong matira na to, greater than 0. Kasi kung hindi greater than 0 yan, babalik lang sa Earth yung object natin. So, therefore pala, class, kung ganun yung case, the exact velocity natin, the exact escape velocity is when this term is equal to 0. So, kapag equal sa 0 yung vi squared minus 2gr natin, then that is the exact escape velocity ng object. That is the exact escape velocity ng isang object dapat kung aalis siya sa gravity ng Earth. So, in that case, the escape velocity VE is equal to VI when VI squared is equal to 2GR is equal to 0. So, therefore, ito na lang yung gamitin natin na equation. Kasi alam natin na dapat para yung object mo magkaroon ng acceleration, dapat yun yung value ng VI mo kapag ka equal sa 0 to. So, pwede natin ngayong isolve yung escape velocity natin. So, take note, ang gagamitin lang natin is this term. This term equated to 0. So, if we determine that, or if we substitute na yung VE dito, equate natin sa 0, ito yung kakalabasan. We have VE squared minus 2GR is equal to 0. So, gawin natin na nasa isang side lang si VE. O si VE lang pala yung nasa isang side, we will have VE is equal to the square root of 2GR. Now, eto na nga yung class, yung formula natin for solving the escape velocity of an object leaving the Earth's gravity. So, VE is equal to square root of 2GR. So, take note that this equation is also applicable to other objects or heavenly bodies as long as alam natin yung acceleration due to gravity nila saka yung radius nila. Kung napansin nyo class, wala pa naman tayong sinubstitute na mga value, di ba? Initial conditions lang. And yung initial conditions na yon, kung iba yung heavenly bodies, as long as same ng initial conditions, parehas pa rin ng process yung kakalabasan. Pwede mong i-apply to sa ibang planets, ibang heavenly bodies, basta alam mo yung G nila tsaka yung R nila. Ayan. So, i-apply natin sa problem. So, what is the Earth's escape velocity daw? Its radius is 6,371 kilometers and the acceleration due to gravity is 9.81 meters per second squared. So, yung solution natin ngayong class will be, gamitin lang natin yung formula. So, we have VE is equal to square root of 2GR. Given naman yung gravity natin, given din yung radius. So, para uniform tayo, ginawa ko, yung G natin, ginawa ko na times 10 to the negative 3. So, para kilometers na rin siya. Now, calculate lang natin yan. We will arrive at 11.12 kilometers per second. So, therefore pala class, kung ikaw ay isang rocket ship at gusto mong ma-escape yung velocity ng Earth, you need to have an initial velocity of at least 11.12 kilometers per second. So, ganun ka dapat kabilis. So, kung napansin, ang mahirap lang or ang in-applyan lang natin ng differential equations is yung paghahanap ng formula. Pero kapag nagsosolve na tayo, wala na kasi may nakuha na tayong formula So, madali na. However, kung iba ang initial condition, maiiba yung formula natin. Diba ganun naman tayo yung ginagawa natin sa mga previous na discussion. Pag iniba mo yung initial condition, maiiba yung constant mo, diba? So, maiiba yung buong formula mo. So, pag sinabi sa problem na nag-start siya at an altitude na ganito kataas. So, maiiba yung radius mo doon. Tapos, maiiba din yung gravity mo at that point. Pwedeng, dahil mas mataas ka, yung altitude nung pinagsimulan, mas mababa din yung gravity. So, kumbaga, possible na ganun yung mangyari. Next example. So, the radius of the moon is roughly 1,080 miles. The acceleration due to gravity at the surface of the moon is about 16.5% of the Earth's acceleration due to gravity. So, determine the escape velocity from the moon. So, ang pinapahanap naman sa atin ngayong class is the escape velocity of the moon. So, to do that, we'll just have to use the formula as well. So, again, yung formula natin for escape velocity, that is equal to square root of 2GR. But this time around, hindi na yung G ng Earth tsaka R ng Earth yung gagamitin natin. However, ang sabi dito, 16.5% daw ng gravity ng Earth yung gravity ng Moon. So, kunin na lang natin yung 16.5% nung 9.81 meters per second. But since ang given is naka-miles, yung radius natin naka-miles, ang pwede nyong gawin, either i-convert natin yung G into miles per second squared or i-convert natin yung RM into meters. Basta as long as dapat lang naman pareha sila ng value. So yung RM natin, given yan, that is 1080 miles. Tapos yung GM natin, RM is radius ng moon, GM is gravity ng moon. That is 0.165 daw or 16.5% ng G natin. And yung G natin class, pag in-express natin yung miles, it is 6.09 times 10 to the negative 3 miles per second squared. So, hanapin muna natin yung GM. So, 0.165 times the gravity of Earth in miles per second squared. We will arrive at a GM na 1.00485 times 10 to the negative 3 miles per second squared. So, pwede na natin ngayong hanapin yung escape velocity ng moon. Substituting it to the equation, we have VE is equal to the square root of 2 times G, which is 1.00485 times 10 to the negative 3, times RM, which is 1080 or 1080. Pag ginagawin natin yan, we will arrive at an escape velocity of 1.473 miles per second. So, this is our final answer. Ayun. So, that is how we solve differential equations class. or that is how we solve escape velocity using differential equations. So that is it for this video.